All right, hello, welcome back.
Are now in a new podcast. We're going to talk about thermal heat and a new term that you haven't heard of, heat capacity.
All right.
So let's go ahead.
6.4, 6 or 7.4.
Yep. Units to measure energy. We talked a little bit about joules and calories last time, but now I want to give you the formal definition. So a calorie you've probably heard of because of chip
Calories.
bag, right? And so actually me and her have cleaned out this chip bag, and we did something before, and we'll show you a video clip later on about how many calories are actually
And so a calorie is actually the energy to raise 1 gram of a substance 1 degree Celsius.
1 degree Celsius. And this is it's going to be 1 gram of water is what we are going.
So instead of just a general substance, let's be more specific.
And this says it has 240 calories in this, but food calories are slightly different. Food calories are actually 1,000 calories. So when you read 1 calorie on a food bag, it's actually 1 kcal, or kilo means 1,000 calories.
So those 100-calorie bags of chips, not really.
They're actually 100,000 calories, so kind of rough. The SI unit for energy, so just like the SI unit for mass is kilograms, and the SI unit for distance or length is meters, and such. But for energy, it's named after this old dude named James Joule.
1818 to 1889. Basically what a joule is the basic unit of energy. 4.18 joules equals 1 calorie.
So this is another conversion factor that we will be
Working with.
Okay. So how do we measure energy? Well, we use water.
Right? We already know everything about it. We generally can find the mass pretty easily because mass is equal to its volume. We know the temperature of water. We can use a thermometer. And we know the specific heat.
Now this is a new definition. Specific heat is basically the amount of energy that's required to heat 1 gram of a substance. So if I have 1 gram, in order to heat that up 1 degree Celsius more, it's going to take 4.18
If you're talking about water.
if you're taking about water. So like a metal might be less. Water is actually a pretty high heat capacity.
Yeah.
That's why rivers and lakes, it takes so long to heat those things up during the summer, and it takes a long time to cool them down in the winter. This is the equation you're going to be using. You have an interesting name for this.
We call it MCAT. So we
MCAT.
say Q equals MCAT because that delta there, remember delta means change, kind of looks like a funny looking A.
Okay, so we can call it MCAT. M stands for mass.
And mass is measured in grams.
This C is heat capacity.
And what's the unit on that?
And the unit on that can get real funky, but let me go ahead and write this. So mass is typically in grams. And we'll do heat capacity is going to be energy per gram times a change in temperature, so it's grams degrees Celsius. That'll make more sense when we're canceling things.
Yep.
And then temperature, we're always going to record in
Degrees
Celsius or
Celsius.
Kelvin. And so this is change in T. Remember, change in T means final minus initial. So
Which means that Q's unit is going to be just joules.
let's come over here. Grams are on top, so grams cancel with grams, and degrees Celsius cancels with degrees Celsius. So our units for
Q, which
Q,
is heat.
which is heat, joules
Yeah.
or calories. Right?
And we can just convert between those pretty easily.
Using the conversion factor. So this is not a Cheeto, but we've got a Ruffles energy bit. So let's go ahead and see how many.
Yep, and it's
What
actually
we're going to do is we're going to figure out how much energy is packed into one chip of our Ruffles back here. So the first thing we need to do, mass of chip, we've got 1.0 grams. That's pretty easy. And we're going to burn this chip so that all the chemical potential energy that's stored in the chemical bonds, those empty calories, is going to be released as energy. And then that energy is going to be released as heat to heat this water. We'll measure the temperature change to see how much energy was released. So we have taken the initial temperature of our water, and it looks about 22.5, 22.6, so that's T initial. And then the mass of our water, we poured 20 milliliters, which is equal to 20 grams of our water. So let's go ahead and do it. First we will light. All right. And we will burn the chip first. It's all good. Okay. Hope we can get it flaming. There we go. Now, the energy in here, as it's burning, all the bonds, I don't want to blow it out, all the bonds are breaking and are being released as heat, and the heat is being, if I can keep the heat from escaping, should all go to heat this water here. I might lower this. That way we don't lose any heat. So we're losing a little heat. Okay. And last bonds are breaking and releasing energy, and it's out. Try and clog this so it doesn't leak. Let's come look at our temperature. Still climbing. We're going to wait till it evens out. Stir it a little bit. Here, I'll let you. Still at 48.1, 48.0. That looks like we're holding at 48. Okay, so that's our final. And you can see not all of the chip was burned. Some of it's still left, so we could maybe say maybe half the chip didn't burn. So we might want to just take that into consideration. We'll pretend that it all burned. And it's going back down. So our final is about 48.0 degrees C. So let's figure out how many calories are in that.
So let's go ahead and let's do our calculation. So let's first write down what we knew, and then we'll record our data. So we knew our mass of water was 20 grams, and if you we recorded our temperature initial was.
Our temperature initial was. We're gonna go look over there.
She's gonna run over there, and we had our temperature final.
Was 48 degrees was final, and 22.6 was initial.
Okay, 48.0 degrees Celsius and 22.6 degrees Celsius. And if we think back to our thermal energy equation, it was Q equals
MCAT,
MC delta T. So we need C, and remember C for water is 4.18 joules per gram degrees Celsius.
Okay.
Okay, so let's go ahead and see how much heat was absorbed, absorbed meaning endothermic,
taken in
by our water. So this is going to be Q water.
And the reason why we're checking out how much was absorbed by the water is because, remember, energy can't be created or destroyed. So we're assuming that the energy we lost by burning that chip is going to be equal to the energy gained by that water. So we're just writing out all the little baby steps.
Okay, let's go ahead, and all we're going to do is we're going to go through and plug in. So we have mass of water equaled 20 grams, so I'll put that in parentheses, 20 grams. And our heat capacity of water,
4.18 joules per gram degrees Celsius.
Always important to write your units.
That way you know that everything cancels.
Yes. Okay. Temperature final,
48.
48. And I'm running out of room. Minus 22.6.
Oh, we just made it.
Degrees C. Okay. Let's go ahead and get ready to cancel. And we got to go to in color to do that. Grams is on top here and on bottom here. So
let's go ahead and cancel those.
And I can show you the railroad track method here and again. And Celsius cancels with Celsius. So let's go ahead and do our math. We'll have 20 grams times 4.18 joules degrees C grams times 48 minus 22.6 is going to be
15.4.
Thank you. Okay, now we've got everything that we can multiply, so let's go over. Okay, we've got 20 times 4.18 times 15.4. And I get 1287.44. All right.
1287.44. And what's the unit?
Yeah, remember we're just doing Q, and Q is in units of joules, so this is joules. Okay, so that was the amount of heat absorbed by the water. Let's convert this to kilojoules. Come on over here. If we've got 1287.44 joules, and I want to go to kilojoules. Remember, there are 1,000 joules in 1 kilo. 1,000 means kilo. So I know we haven't done this a whole lot, but divided by basically is the same as moving the decimal place 3 times to the left, and I get 1 point, I'm going to round to 29, and this is going to be kilojoules. So I have 1.29 kilojoules, but that's not what my bag is in. My bag is in calories, which is actually kilocalories. So let's go ahead and convert this. 1.29 kilojoules okay, and remember how many joules are in a calorie?
4.18.
Yeah, so we got 4.18, and if we use kilo both times, it works just the same, so it's 1 kilocalorie and 1 kilojoule, and we can do that math. When we come over here, and I can actually just divide by 1,000, and I'll have my number already.
Because that answer is already up and in there.
And so I got 1.29 divided by 4.18, and I get 0.31, about.
All right.
Or 0.31 calories.
Now, let's take into account the fact that we only burned about half of our chip.
I only burned about half chip, so maybe it's probably closer to 0.6 or something like that. And so you're actually getting about almost a whole full 1,000 calories or 1 kilocalorie in one chip. In one chip. So that's a lot of empty calories.
Okay.